Lesson 40, I will solve word problems involving fractions. So lesson 40 is going to be very similar to what we did in lesson 39. We're going to be problem solving using the RDW strategy, but we're going to be doing something a little bit different. In lesson 39, we were using the multiplication comparison where we were saying this is 5 times as much or 3 times as much. And in this lesson, the problems will be just a little bit different. All right, so let's talk about expectations whenever you're problem solving, first of all. Whenever you are getting ready to, after you read the problem, obviously we're going to start with R, which means to read, but the next thing that we really need to focus on is that D, modeling the problem. We talked about this in the last lesson, how we have a lot of trouble wanting to model that problem and that we often want to just leave that part out, but it's very, very important. You have to model and then you have to think about what conclusions can you make from your drawing. Then it's time to calculate and solve the problem and write a statement. All right, so let's take a look. We're going to get right straight to our problem set today. There is no practice in our math journals today. We're just going to go right straight to the problem set. So you're going to notice in problem 1, it says the chart above and to the right shows the heights in feet of some football players. Use the data to create a line plot at the bottom of this page and to answer the questions below. So that's what we're going to begin with, okay? We're going to begin by creating our line plot. So the first thing I want you to do is I want you to get a ruler because you're going to need to make a straight line. Okay, and once you get your ruler, we're going to go ahead and draw our line. Remember, lines have arrows on both ends to show that they continue on in both directions. All right, so the next thing we're going to look at is we're just going to take a look at our data. And I'm looking to see what is the smallest number that I have here. So first of all, I look at my whole numbers and I see 6, 5, 6, 6, 6, 5, 6, 6, 5, 6. So what that tells me is if I make my line plot, or my line, if I make my number line starting with the number 5 and I end at the number 7, then I should have plenty of spaces for all of these numbers and all this data that I want to plot on my line. Okay, so I've got 5, 6, and 7. Now, I notice when I look at my fractions, I have fourths, eighths, halves. Fourths, eighths, ace, ace, ace. So the good thing about fourths, halves, and ace is that all of these are related numbers. If you think about the numbers 4, 8, and 2, these all could be part of a fact family, right? 2 times 4 is 8. 4 times 2 is 8. 8 divided by 2 is 4. So I know that if I go with eighths when I'm making my number line, I can still do halves and I can still do fourths. So I'm going to go ahead and divide both of these wholes into 8 parts. I'm going to start by dividing this into half, and then I'm going to divide it into fourths. I want these to be as even as possible. And I'm going to come through and divide all of these fourths and halves so that now I have eighths. I'm going to do the same thing over here. So I'm going to go half, and then I'm going to half my halves to make fourths. And I'm come through and draw a line in between all of the fourths to make eighths. Okay, I'm not going to go through here and label all of these, but let's just go through here and count them to make sure that we know what everything is. So I've got 5, and this would be 5 and 1 eighths, 5 and 2 eighths, 5 and 3 eighths, 5 and 4 eighths, 5 and 5 eighths, 5 and 6 eighths, 5 and 7 eighths, 5 and 8 eighths, or 6, 6 and 1 eighth, 6 and 2 eighths, 6 and 3 eighths, 6 and 4 eighths, 6 and 5 eighths, 6 and 6 eighths, 6 and 7 eighths, 6 and 8 eighths, or 7. All right, so now we're going to plot our data. So the very first number that I have is 6 and 1/4. So remember, these are eighths. These are eighths, but if I count every other one, I have fourths, right? So let's just look at this in red for a minute, okay? So these are my fourths. I have 1/4, 2/4, 3/4, 4/4. So if I want to come through here and plot 6 and 1/4, I would put an X right here. And I'm going to go ahead and label this 6 and 1/4. And then I'm going to put a check mark by this one. All right, so now let's do 5 and 7 eighths. 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths. 5 and 7 eighths. So let's check it off. All right, so now I've got to do 6 1/2. So if these are eighths, I can just count over how many eighths are in a half. What's half of 8? 4. So 6 and 4/8 is half. So 1/8, 2/8, 3/8, 4/8. This is the same thing as 6 and a half. Now I've got another 6 and 1/4, and I've already got that labeled, so I can just go over here and put an X up here. And now I've got 6 and 2/8. So I've got 6 and 1/8, 6 and 2/8, which is the same thing as 6 and 1/4. If you wanted to, you can come right underneath this 6 and 1/4 and label this 6 and 2/8 to help you remember that those are equivalent. And then I've got another 5 and 7/8. Now I've got 6 and 1/8. So this is 6 and 1/8 right here. 6 and 5/8. So 1/8, 2/8, 3/8, 4/8, 5/8. 5 and 6/8. That's going to be right before 5 and 7/8. And another 6 and 1/8. So this is our line plot. So when you look at your line plot, there are some things that you can I'm going to go ahead and label this 5 and 6/8. There are a couple of things that you can notice. First of all, which height is the most common? Well, there are 3 players that are 6 and 1/4 feet tall or 6 and 2/8 feet tall. Okay, now we're ready to solve some problems using our line plot. What is the difference in the height of the tallest and the shortest players? So which player would be the tallest? Well, the tallest player would be 6 and 5/8. So I've got the tallest player, who is 6 and 5/8. So remember, I'm going to be modeling this. 6 and 5/8. And then the shortest player, so I'm going to put S for shortest, which would be 5 and 6/8. And they're asking for the difference. Where would the difference be in this diagram here, or this model? Well, the difference would be this area right here. How much area there is from the shortest player to the tallest player. So this is what I'm trying to find out. So what would my number sentence be? I would use subtraction, right? 6 and 5/8 minus 5 and 6/8. So my first thought is, well, I can say 6 minus 5 is 1. I could do that. But I cannot say 5/8 minus 6/8 because this is larger. So you're going to have to think back to when we decompose these. I'm going to have to decompose this. One of the strategies that we used when we were subtracting mixed numbers is we took this whole number and we took one away. So I would make this 5. And then I would take that whole number, which would be 8/8. And put it right here. Okay, so I still have this 5/8. Okay, so I've decomposed this 6 into 5 and 8/8. Now what I'm going to do is I'm going to say 6 and 5/8 minus 5 and 6/8 is the same thing as 5 and 8/8 minus 5 and 6/8. Now watch this. Plus 5/8. I don't want to forget about this over here, okay? So now I'm going to solve this. 5 minus 5 is 0. 8/8 minus 6/8 is 2/8. So I just subtracted 5 and 8/8 minus 5 and 6/8. Now I'm going to add this 5/8 back, and my answer is 7/8. So what's the difference in the height of the tallest and shortest players? I'm just going to say the difference is 7/8 of a foot. Okay, let's move on to part B of this problem. Now it says player I and player I and player B have a combined height that is 1 1/8 feet taller than a school bus. What is the height of a school bus? Now this is where it's really important to model this problem, okay? So let's think about what it's saying. When it says they have a combined height, what does that mean? Well, that means when you combine their heights. Well, when you combine something, you put it together. So let's take a tape diagram and let's put player I and player B's heights together. So player I is 5 and 6/8 feet, and player B is 5 and 7/8 feet. Now it says that, I'm going to call this I and B. It says that this height is 1 and 1/8 feet taller than a school bus. So I'm going to go ahead and label the school bus. I'm going to call it SB. So the school bus is shorter than this combined height, because look at what it says. This combined height is 1 and 1/8 feet taller. So that means that the school bus is shorter than their combined heights. How much shorter is it? 1 and 1/8 feet. So what is the part that I'm trying to figure out? Well, the question says, what is the height of a school bus? So this is what I'm trying to find out. So what would be my first step here? Well, I hope that you said my first step is to put these two numbers together. First, I have to figure out what this combined height is. So I've got 5 and 6/8 plus 5 and 7/8. Well, if I add my whole numbers, that is 10. And if I add my fractions, that is 13/8. Well, I can't leave this an improper fraction, so I'm going to go ahead and use a number bond and make this 8/8 and 5/8. So that gives me 10 plus 8/8 is 1 whole, and then my 5/8. So together, this would equal 11 and 5/8. So this is how tall player I and player B are together. So I'm just going to come over here and I'm going to do like this. 11 and 5/8. So now I'm trying to figure out if this is 11 and 5/8 and I'm trying to figure out what this is. What am I going to do with this 1 and 1/8? Am I going to add them? Well, if I add them, am I going to get a number that is smaller because this is smaller? No, I'm going to get a number that's bigger. So I want to subtract. So I'm going to take 11 and 5/8 minus 1 and 1/8. So because 1/8 is smaller than 5/8, I don't have to do anything special. I can just subtract my whole numbers. 11 minus 1 is 10. And I can subtract my fractions. 5/8 minus 1/8 is 4/8. So the question I'm trying to answer is, what is the height of a school bus? So I'm going to say the height of a school bus is 10 and 4/8 feet. Okay? All right, so now let's take a look at problem number 2. One of the players on the team is now 4 times as tall as he was at birth when he measured 1 and 5/8 feet. Who is the player? Okay, so what can we draw here? Well, we can start by drawing how tall the player was at birth. So I'm going to label this B. So how big was he at birth? He was 1 and 5/8 feet. And it says now, so I'm going to call that N, now he is how many times as tall? 4 times as tall. So that means I'm going to make 4 1 and 5/8. So let's think about what's the question asking. Well, first of all, it asks who is the player. So before I can figure out who is the player, what am I going to have to solve for here? Well, I'm going to have to solve for how tall the player is now. So what could I do to solve this? Well, I could use repeated addition. I could say 1 and 5/8 plus 1 and 5/8 plus 1 and 5/8 plus 1 and 5/8. Or I could say 4 times 1 and 5/8. So remember when we solved these whole number times a mixed number problems before, we used the distributive property. And we said this is the same thing as 4 times 1 plus 4 times 5/8. So 4 times 1 would be 4, and 4 times 5/8 would be 20/8. So I have to take this improper fraction and make it into a mixed number. So if I counted by eighths, I would get 16/8, and then I would have 4/8 left over. So now I would have 4 plus my 16/8, which is 2, and then my 4/8. So altogether, that would be 6 and 4/8. But notice it doesn't ask how tall is the player. It asks who is the player. So I have to come over here to our chart and see who is 6 and 4/8. What do you notice? There's not a 6 and 4/8. Do you notice a number that's equivalent to 6 and 4/8? What do you know about 4/8? Well, I know 4 is half of 8. So is this equivalent 6 and 1/2? Do you see a 6 and 1/2? I do, right here. So who is the player? The player is player C. Okay? All right, moving on to problem number 3. 6 of the players on the team weigh over 300 pounds. Doctors recommend that players of this size drink at least 3 3/4 quarts of water each day. At least how much water should be consumed per day by all 6 players? Okay, so we've got 6 players, and they're going to drink 3 3/4 quarts of water each day. So I don't hear any kind of comparison there. So I'm just going to draw a tape diagram that has a total here. So I'm going to divide this into 6 parts because I have 6 players, right? Now, how much water does each player have to drink every day? Well, it says 3 3/4. So I've got 3 3/4, 3 3/4. So I'm going to go ahead and write this 6 times. 3 3/4. So what am I trying to solve for here? I'm trying to solve for the total. So what could I do to figure out what this is altogether? Well, it's kind of like the problem that we just did, right? We could do a repeated addition, or we could use multiplication. We could say 6 times 3 3/4. So remember, that's the same thing as using the distributive property. We're going to say 6 times 3 plus 6 times 3/4. So now we're just going to solve. 6 times 3 is 18, plus 6 times 3/4 is 18/4. So what am I going to do with this 18/4? It's an improper fraction, right? So I'm going to kind of do this, my number bond, over to the side. And if I counted by 4s, I could get all the way to 16 without going over. So I've got 16/4 and 2/4. So now I've got 18 plus, and then when I look over here at my 16/4, this is 4/4 4 times, because 4 times 4 is 16. So that's the same as a whole number 4 and 2/4. So when I add these together, 18 plus 4, I have 22 and 2/4. So let's go back up here and look at the question. At least how much water should be consumed per day by all 6 players? So, and these are quarts, I believe. Yes, quarts. So my answer is the players should consume at least 22 2/4 quarts daily. Okay? All right, moving right along. All right, now we have problem number 4. 9 of the players on the team weigh about 200 pounds. Doctors recommend that people of this weight each eat 7 7/10 grams of protein per pound each day. About how many combined grams of protein should these 9 players eat per day? Okay, so let's think about this for a minute. The first part that kind of confused me was, I'm not sure what it says grams of protein per pound each day. I'm not really sure what they mean by this. But we're not gonna concern ourselves with that, okay? We're just gonna say, all right, each player has to have 7 7/10 grams of protein each day. So how many players are there? There are 9 players. So if I made my tape diagram here, and I broke it down into 9 parts, so that means I'm gonna make 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we're going to write 7 7/10 9 times. And I know that gets a little bit tiring, but it won't hurt. Okay, so we've got 7 7/10 for every single one of these players. So while I'm finishing this up, let's think about what are we trying to figure out here? We're trying to figure out a total, right? So our question mark would be, how much is this all together? So we could do repeated addition, or we could use multiplication. I have 7 7/10 9 times, so I could say 9 times 7 7/10. I want you to pause the video at this time, and I want you to try to solve this all by yourself. If you get stuck, you can always come back and play, but it's really important that you at least try to do as much of this as you can, and then come back and press play. And once you get going, you can always pause it again and try to finish it. All right, so pause the video at this time and try to do this by yourself. Okay, so hopefully you attempted to do this by yourself. We're going to use the distributive property. So we're going to say 9 times 7 plus 9 times 7/10. All right, 9 times 7 would be 63, and 9 times 7/10 would be 63 tenths. So I can't leave this as an improper fraction. If I counted by tens, I would get to 60 tens before I went over, and that would leave 3 tenths left over. So now I've got 63 plus 60 tenths is 6 and 3 tenths. Now when I add these together, that gives me 69 and 3 tenths. So what's the question again? About how many combined grams of protein should these 9 players eat per day? So the players should eat about 69 3/10 grams of protein. So you might be thinking to yourself, but Miss Jennings, they use the word about, and about means that I have to estimate. And typically it does mean that you have to estimate. But the only reason why we don't have to estimate is because it says here that they should each eat about 7 7/10 grams of protein. So what that means is that the doctor's not recommending that they eat exactly 69 3/10 grams of protein, but they're saying that they eat about that much. That's why we did not have to estimate our answer, because back up here, when they were given the facts of the problem, they were already saying that this was an estimated amount, that the doctors were estimating that they needed to eat about this much. So that's why we didn't have to estimate. Okay, because I know sometimes that can be confusing to students. All right, so whenever you are solving your problems, make sure that you are always modeling, 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 modeling. When you get ready to do your exit slip, come back and look at these 4 problems that we've already done together. You can probably find a problem that's similar to what you need to do on your exit slip.